Hello guys! Many of us love playing video games. Personally, I love playing with a gamepad. Even though my native platform is PC, not console, with a gamepad, gaming feels like real relaxation. If you work at a computer all day and also love video games, then when you play, a keyboard and mouse can feel a bit like work, and it becomes harder to fully unwind. But with a gamepad, the feeling is totally different. It might seem a bit uncomfortable the first time you use it, but you get used to it very quickly and start noticing its advantages. A gamepad is more portable than a keyboard and mouse. You don't need a desk. You can play even lying on a couch or sitting in a chair in any position, while eating chips and washing it down with cola. But wireless gamepads have one problem. From time to time you have to charge them. It's not that serious because, first, high-quality expensive gamepads with good batteries can last up to 30 hours of continuous gameplay without recharging. Second, you can put your gamepad on charge every time you go to sleep. Third, you can play while charging from a power bank. All of that is true, but not in the case of today's hero. The model I'm holding in my hand is cheap compared to original controllers from Xbox, Nintendo or PlayStation. But it's still comfortable and wireless. Unfortunately, it doesn't have a built-in battery. It only has compartment for AA batteries. And if you are a real gamer, you know what that means. Roughly 8 to 12 batteries per month. And in my opinion, it's already a real problem. And that's exactly what we are going to fix in this video. You are watching Logic Gate Labs, let's get started. The first thing that comes to mind is using nickel metal hydride rechargeable batteries like this. But it's not the best option. The thing is, these batteries are decent, but they discharge faster during use and have less stable voltage. They self-discharge faster compared to lithium polymer or lithium-ion batteries. That means even when you are not using them, they quickly lose their charge. You have to constantly take them out of the controller to recharge them, which personally is exactly why I decided to make this video. And as you can guess, this USB Type-C port, even if you plug it into power, won't charge AA rechargeable batteries. And that makes sense, because you never know what the controller owner put in there, regular batteries or rechargeables. If controller designers allowed this kind of charging, there would be a lot more fires in the world. And this applies not only to a no-name controller like this, but also to an Xbox controller. You can charge AA rechargeables inside it either. Xbox controllers have an additional solution in case gamers get tired of constantly replacing batteries. Look at this extra contacts inside the battery compartment. In an Xbox controller, you can insert a battery pack like the one you see on the screen. It can be made by Microsoft or third-party manufacturers. In this case, it's original, but it usually doesn't come included. Even though it supplies power through the same contacts as AA batteries, it charges through these small contacts. If you look at third-party battery packs, we'll see that those small contacts are often used less frequently, but they usually have their own solutions to avoid constantly removing the battery. For example, this battery pack, unlike the original Xbox One, lets you charge the controller on a docking station if you have one. And you can also charge it separately via USB Type-C. And this battery pack only supports charging via USB Type-C. Coming back to the original Xbox battery pack with its extra contacts, we can say this. Both the battery and the controller are designed quite well. The engineers considered situations where gamers might get annoyed and they found solutions. Respect for that. But in case of no-name controllers, that kind of battery pack won't work, because there are no small charging contacts. Third-party manufacturers don't really make battery packs for controllers this unpopular. Some models might fit in size, but either the cover won't close or will end up with two USB Type-C ports, which opens the door to mistakes. So that's exactly what we are going to do. We'll try to create our own battery. One you won't have to remove from the compartment every time it runs out, and one that can be charged from a single USB Type-C connection. But first, let's look at what's inside non-official Xbox controller battery packs. As we can see, nothing extraordinary. 2 AAA rechargeable cells and a charging controller. And in this battery pack, unlike the previous one, the charging controller is very small. One of the smallest I've ever seen. Thanks to that, the designers were able to fit larger capacity cells inside. Let's see what we need to build our own battery. The power source will be this lithium polymer battery rated at 920 mAh. It's compact and its capacity is even higher than many built-in batteries in controllers of the same category. For example, one of these controllers has a 600 mAh battery. To charge our battery, we'll use a TP4056 charging module. A lithium polymer battery outputs between 3.2 and 4.2 volts depending on the charge level. But that's too high for this controller. It needs only about 2.5 to 3 volts. So we need a step-down converter. The MT3608 isn't a good fit because of its size. But the MP2307 is much smaller. That's what we'll use. The enclosure will be made from acrylic. And to deliver power to the controller contacts, we'll use these small terminals meant for AAA batteries. Let's try to assemble everything into one device. From the acrylic sheet, we cut enclosure parts sized to fit into the controller's battery compartment. The holes will be positioned so that the battery can fit between them. But before using PCB standoffs, as the enclosure supports, we need to prepare them. If we want reliable contacts with the controller's terminals, these battery terminals must be firmly attached to something, for example to PCB standoffs. We'll attach them by soldering. The terminals should stick out of the enclosure a little to ensure solid contact. To achieve this, we need to add a lot of solder between the standoff and the terminal. And we get a result like this. Inside the enclosure, the terminals will be fixed like this. The power system itself isn't very thick, but if we mount it with screws like in my previous project, it won't fit into the battery compartment. So we'll use a superglue after making a recess in the top part of the enclosure. This recess gives us a bit more space, and the uneven surface gives the glue mechanical grip between the PCB and the enclosure. We end up with this. But that's not everything. The controller itself has to power this battery from the inside. Otherwise, our battery is no different from the regular AA batteries. To figure out how to do that, we need to open the controller. Right away, we see two contacts that might work. Let's measure the voltage. And yes, these 5 volts are just what we need. Now we need to solder a USB Type-C connector to the contacts we found. This connector can easily be pushed through the opening, where it will line up with the battery pack's port. But unfortunately, this isn't the best idea. The Type-C shell is metal and electrically connected to ground. That means if it touches the controller's plus terminal, we'll get a guaranteed short circuit. And the distance between the Type-C connector and the terminals is very small. At some point we will definitely touch the plus contact with the metal shell. A solution is a JST connector like this, with a solid and reliable housing that makes a short circuit impossible. Unfortunately, we'll have to get rid of USB Type-C. It's not very pleasant, because we won't be able to charge the battery separately from the controller without a JST adapter. But that's the price we pay for safety. This is what the battery pack will look like without USB Type-C. If we keep talking about safety, we can add extra insulation to the battery so that possible friction between the standoffs and the battery doesn't lead to holes in the Kapton tape. Let's check that the output voltage is correct. And make sure the controller actually works with this battery pack. Now, going back to JST connector, which will let us charge the battery without removing it, we need to slightly modify the enclosure. More specifically, remove this part so the connector can pass through. As we can see, the connector can be either inside the enclosure or outside. Sometimes it's a bit hard to pull it out, but it's still possible. And with a permanent battery inside, it's not something that you'll need to do often anyway. Don't forget to solder the connector to the battery itself and check whether charging works. And yes, it's charging. Let's test that everything works. We connect the battery pack to the controller. Close the cover. And yes, it works. So what do we get in the end? A higher capacity battery than controllers in the same price category. You don't need to remove the battery pack to recharge it. The original port can now do it. The battery pack is removable. You can still use regular AA batteries if you want. Thank you so much for watching, guys. I hope the video was useful and interesting. See you next time. Take care.